Type a basic character prompt into any AI image generator, and you will likely get something like this. The subject is there, but the exposure is flat, lifeless, and washed out. The AI is simply guessing. Now look at this rendering of the exact same subject. We have deep, deliberate shadows and crisp highlights sculpting the face. Achieving this specific look requires directing the AI exactly like a professional cinematographer working on a physical set. We are going to break down a strict architectural formula that guarantees this level of professional cinematic lighting on every single generation. Open your preferred AI image generator, Midjourney, DALL-E, or Stable Diffusion, and pick a simple subject so you can follow along. High-end AI art happens by design. It requires a deliberate prompt architecture that leaves absolutely nothing to chance. Text-to-image models read your prompt sequentially. Words at the very beginning carry the most semantic weight, and that weight decreases as the prompt goes on. If you type your lighting instructions before your subject, the model gets confused. It will often try to generate abstract blobs of light instead of illuminating your actual character. This diagram outlines the rigid sequence we use: subject, details, style, composition, lighting, and quality. Start your prompt by writing out your subject and camera angle. Fill in these initial blocks to establish physical geometry before adding any illumination. By locking the lighting command into this exact fifth position, you ensure the AI already knows the physical shape of your subject and can map the light factors directly onto it. Next, look at the vocabulary you are using. Adjectives like dramatic, moody, or epic are junk words that actively degrade your image. The neural network interprets those vague terms by pulling from vast datasets of low-quality consumer photos. It applies generic stock photo filters instead of calculating real light physics. You fix this by deleting the adjectives and replacing them with specific optical and studio vocabulary. This split screen shows the result of a term like Rembrandt lighting. Notice the signature triangle of light sitting directly on the subject's shadowed cheek. For outdoor environments, this image demonstrates practical urban light colors. Using Neon City or sodium vapor instructs the model to render distinct glowing street lamps. Pick one specific optical term that fits your scene and drop it into the lighting block of your prompt. Supplying precise terminology forces the AI to bypass consumer snapshot data and pull exclusively from professional photography datasets. Look at these overhead studio lights. Professional cinematographers shape a scene by physically positioning hardware, and your prompt needs to mimic this physical placement. Name the exact physical light modifier you want. Tell the model to use a single softbox at 45 degrees, or a Fresnel spotlight. Then, define the color temperature of that source. Specify a warm tungsten desk lamp or a cool 6500 Kelvin monitor glow. Creating a light source is only half the process. Commanding the absence of light is just as critical. Add a direct shadow command to your lighting block, such as pitch black background or high contrast ratio. When you pair a defined physical light source with a deliberate shadow command, the AI generates true three-dimensional depth on a two-dimensional screen. Methodically execute your prompt and carefully examine the generated four-panel image grid to see how the model interpreted your commands. That initial output is rarely perfect. There will usually be some artifacts or light spill that requires refinement. To fix it, we use the one variable rule. If you rewrite the entire prompt, the AI will re-roll the whole scene, losing the geometry and structure you already built. Instead, isolate the problem. Swap out exactly one lighting word, change softbox to diffused window light, and hit generate again. Disciplined single variable iteration isolates the model's exact response to your command, giving you predictable control over the final output. Here is the final rendered image. You can see exactly where our commands manifested. The cheek triangle proves the 45-degree angle worked, and the deep background shadows show our contrast ratio command took hold. Rely on the structural formula, employ precise optical vocabulary, and iterate one variable at a time. Check the video description below for additional resources. Copy the core lighting prompt template and our cheat sheet of 10 keywords so you can immediately apply this lighting architecture to your next project.